This is csf4203, week 4, chapter 8. Okay. In this chapter, we are going to discuss about the TCP IP suite of protocols. Why do we need a protocol? Why do we need a protocol? We need a protocol because for computer communication, we need to standardize the exchange of information between computers for the purpose of cooperative actions. They need to have a standard of communication. For computer network, two or more computers interconnected via a communication network, they can communicate with each other if they know the protocol. They need to speak the same language or translate the language. Also, a protocol is used for communication between entities in different systems. What is entity? Entity is anything capable of sending or receiving information. For example, your application, file transfer packages, database management systems. These are entities. So entities is not only users. System is a physically distinct object that contains one or more entities. For example, computer, terminal, okay? Protocol is a set of rules governing the exchange of data between entities. We have key elements for a protocol, like a language. Language has some key elements, words, verbs. Protocol has syntax, includes such things as data format and signal levels. Syntax. We have semantics, includes control information for coordination and error handling. This is done by the semantics. Then we have timing, or synchronizing, or timing, or clock. Includes speed matching and sequencing. These are three key elements of a protocol. So why we need to have standards for protocol? Why don't everyone have their own protocol? Is this good?
That should be the same.
Yeah, before like HP, they have their own. If you buy like a telephony system from in the old days, like from some companies, Radisson, or it will not work, Ericsson, it will not work with other telephone sets from other companies because they are not using the same standards. So vendors like standards. Yeah, Mister, please. Vendors like standards because they make their products more marketable. I can sell more. Customers also like standards because they enable products from different vendors. Like you can buy a mouse from your laptop can be Dell, but the mouse can be from HP, no problem. Okay. Also, two protocol architecture have served. They are the most famous one, which is TCP IP and OSI. OSI, how many layers? Very good. A widely used proprietary scheme is a proprietary, and it's only for that company. Proprietary and only خصوصي for that company. One of these proprietary is IBM SNA. OSI, TCP IP is open standard. Anyone can use. Proprietary for IBM is SNA. Okay?
Yes.
According to our lecture, TCP IP here is 5 layers. Some books say it's 4. We will follow our book. In the exam, I ask you how many layers. You tell me it's 4 because it's mentioned in another book. You lose mark. So please, we will follow our book. Some other books, they say 4, but we follow our book. Okay? Application layer, transport layer, network layer, data link layer, and physical. Each layer interacts with its immediate adjacent layer. So at the source, the application layer makes use of the services of the transport layer and provides data down to that layer. And here we will show you now the layers. And in the destination, the opposite will happen. Okay. TCP, the most commonly used protocol, which layer? TCP, transport layer. Okay. Because you see TCP slash IP. TCP is the most commonly used transport layer. And we have the IP. The IP is the internet layer. Yani, if you come back here, TCP is on which layer? Layer 4, transport, because we start counting from here. 1, 2, 3, 4. Layer 4. IP, layer 3. Some people call it internet layer. Okay.
It's correct, that's also internet layer, right?
Yeah. The network access layer provides the attached network with the information needed to reach a router that connects to the network to the next network. Okay. The physical layer at the end is connected with the cable. Okay. It's specifying the characteristics of the transmission medium, the nature of the signal, the data rate, and related matters. Okay. There are some explanations here. Please, I strongly recommend that you read them. Some of them are repeated in the slides, but also I strongly recommend that you read them. PDU. The combination of data from the next higher layer and control information is known as protocol data unit. Yani I'll give you an example here. Look at this slide, very important slide. I think I am not changing here, so I am here. We were following on the PowerPoint itself. Okay, here. So the data in the application layer, what do we have? Data. So the PDU name is data. When it goes to the transport will add some information to it, some control. It's like when you write a letter. You need to put some control, yani to whom, from whom, what's the subject, is it priority or no priority? These are control information. So, in the transport layer, the PDU is called segment. Okay, segment. When it reaches the network also will add some more control to it. It's called datagram or packet. Datagram or packet. And then when it reaches the data link will add more control, and it's called a frame. By the way, the data link layer will add header and trailer. The only layer it will add header and trailer. And yeah, header and trailer. Okay, both sides. Okay. Tamam? You have to remember this, please. It is in the physical, it is only bits. So this is what's mentioned here. All right? Sometimes they ask you this as a short answer. What are the PDU stages? TCP and UDP, they are the most famous, the most used protocols in the transport layer. I will provide for you the differences between them. Okay? TCP provides a connection or logical association, and it will do flow control. It will regulate flow check errors. UDP does not maintain a connection, so it is called connectionless. TCP is a connection. It will do connection and then start sending. UDP does not make connection, just sending.
No connection. It's not
reliable. It's not reliable also, very good. Okay, it's not reliable. Okay. TCP guarantee if that segment is not received, if I don't receive acknowledgement that I received the segment, it will retransmit. UDP does not. Okay.
So, when we play videos, it's using UDP, right?
YouTube.
Yeah.
Yeah, some of YouTube, most of YouTube, I think,
Live
using
stream will
UDP.
be UDP.
IP telephony also UDP, and when you are talking to someone on the phone, on IP, if you receive one sentence and one letter is missing, you will receive the letter after.
But if it is UDP, it is also repeater, صح? Or something similar.
Repeater.
Yeah, through the phone.
That's something else. That's for the connection.
Hmm.
But what we say that the UDP is used for IP telephony. For email, TCP, because we need email to be accurate. We don't want word to be changed or letters missing, right? So here we have some summary. TCP is suited for applications that require high reliability. Okay, but the time is not very fast. UDP is for application that needs fast, efficient transmission, such as games. Any questions?
No.
Here we have TCP and UDP headers. You see the UDP header? Not too much information. Source port, destination port, segment length, and checksum. Yalla, transmit. Okay?
Yes.
You go up to the TCP header, source port, destination port, sequence number, acknowledgement number, header length, reserved, flags, and all this information. That's why TCP is not as fast as UDP. So you need to know this, please. Now, these are the protocols in the TCP IP protocol. Here you can see that these are the names of the protocols. You see, these ones, SSH is using TCP, FTP using TCP, HTTP using TCP. SNMP, that's a network protocol, is using UDP. Okay. SMTP is the protocol for email. It is based on what? TCP. Now for IP, these are the protocol, the applications that use IP, ICMP, IGMP, OPSF, OSPF. What are these? This is a network, this is a routing protocol. If you study advanced networking, you will learn about routing protocol. Okay. Okay, now we'll talk about some of these applications. We have TCP, we have SMTP. This is Simple Mail Transfer Protocol. Okay, this is a simple, basic electronic mail facility. It provides mechanism for transferring messages among separate hosts. It has some features such as mailing list, return receipts, and forwarding. We all know about FTP. FTP is used for what? File transfer protocol, sending files. And both text and binary files are accommodated. Binary and like images, maybe things like that. Videos. Provide a secure remote SSH. You know about Telnet and SSH. SSH is more secure. HTTP for browsing. Is HTTP secure? HTTPS is more secure. Okay. It establishes a connection with the server and send HTML pages back to the browser, to the user. We have also SNMP. This is based on UDP, we said. This is Simple Network Management Protocol. It's a widely used network monitoring and control protocol to check the status of your routers, switches. Okay. Any questions?
No.
Routers, what are they? They are used to interconnect networks. The switch cannot do that. Router can do that because it is based on network layer or internet layer. Okay. So these are the essential functions of a router. I think we have some questions like this in the exam. It provides links between networks, routing. Okay. It does not. It provides this without requiring modification of the networking architecture of any of the attached network. Also, these are all features of router or advantages of router. What are the things or characteristics or issues of router? The router must accommodate a number of differences among networks. It is dealing with addressing schemes. You know, address, we have one subnet has an address, subnet mask, the other one has different address scheme. Maximum packet size. So packet from one network may have to be broken into similar pieces. We call this fragmentation. Interfaces. The hardware and software interfaces to various networks are different. Reliability. Operations should not depend on an assumption of network reliability. Okay. Who said the internet is reliable? Alone is not reliable. This is the operation of TCP IP. Please look at it and then I will explain to you some of them. We start from the application here. We are starting from page 1. Read it from your computer, if you like. So here we have the application prepares a block of data. For example, an email or a file FTP or telnet. Then, using a common syntax, if necessary, the data are converted into a form expected by the destination. This may include a different character code or the use of encryption, whatever is needed, or compression. Okay, then it is going to the TCP, the transport layer. TCP may break the data into segments and keeping track of their sequence so that when they arrive, it can assemble them again. Okay. Each TCP segment includes a header containing a sequence number and a frame check sequence to detect errors, all done by TCP. So we are here. Okay. And you can see peer-to-peer dialogue, and application talks to application logically. Duplicating a segment. A copy is made of each TCP segment in case of the loss or damage of a segment. This is done by TCP also. Fragmenting the segment. When it arrives to the IP, remember we said the router, if it's too big, it might break it or fragment it. Okay? And each packet includes a header containing a destination address. What address? IP and source and IP destination. Okay. A frame check sequence and other control information. Also, network talk to network. Framing, when it arrives to the layer number 2, which is network access layer, a frame relay header and trailer are added. Okay, it has many information, contains connection identifier. Trailer has a frame check sequence. All right. So frame is the only one which adds not only header, it adds trailer. Then it goes to the physical link. Physical, each frame is transmitted over the medium as a sequence of bits. Okay. Any questions about this?
No.
Now go to the next one. It is continuing to the opposite. So please continue that one. It is just the opposite. All right.
Doctor, can you please repeat fragmentation?
Fragmentation, when the segment arrives to the packet, to the layer 3, network layer or internet layer, if it's big, it will fragment it, divide it into smaller packets.
Segmentation for the frames to packet. Segment the data to be in the packet.
Not segment, fragment. Fragment data into packets or divide it into packets. Segment is only segment in the transport layer. Be careful. Segment transport. Packet or datagram, network layer. Frame, data link, network access layer, layer 2. Bits, data, very good. Yalla, continue please this one. Any questions about this?
No.
Okay. But I want to tell you here about LLC. Okay.
The formula video.
Yeah, in the frame, in that network access layer, we have the LLC. Okay. It is added to each IP datagram in the form of LLC PDU. The header contains sequence number and address information. So the LLC interacts with the internet layer. The MAC interacts with the physical layer. So we have here in the network access layer two parts. One upper part, LLC, logical link control. It deals with the network layer. The lower one, MAC, deals with the physical. Okay, even with like IP address, things like that. Okay, thank you. So this is the opposite. Now it's going back. See, it arrives here to the physical. At each layer, it will be removing the header or the trailer. Yani when you send a letter, you write the sender and the receiver on the envelope. When it arrives to the receiver, he will remove the envelope. Start removing, okay? Any questions?
No.
We
have another invention.
You said for the receiver will be the opposite.
Yeah.
So, yeah, for the fragmentation, what is the opposite?
It will put them together. The packets, smaller packets, will put them together. Combine them. Okay, let's say I send, for example, a packet. The packet size is too big. Let's say, for example, 100 mega. I divide it into 5 packets of 20 mega. When they arrive there, they will put them together to 100. Okay. Virtual private network was invented to secure the network. It consists of a set of computers that interconnect by means of relatively unsecure network. They use encryption and special protocols for security, such as IPsec. It can secure communication across LAN or private and public WANs and across the internet. Some examples of its use is secure branch office connectivity, remote access over the internet, enhancing electronic commerce security. And you have a branch, you have head branch, bank, talking to each other. How do we secure the connection? Using VPN. And we will study VPN in more details, and we will do a lab on VPN also. So IPsec can encrypt and authenticate all traffic at the IP level. Thus, all distributed applications, all are secure. Anything above the IP layer will be secure. Application, transport will be secure. Okay? an IP security scenario. IP6 operates in network devices such as router or firewall. It will encrypt and compress all traffic going into the WAN. And when it arrives, it will decrypt and decompress. You see what I told you before?
Yes.
The opposite will happen at the receiver. Secure transmission is also possible with individual users who dial into the WAN, اللي هو remote access. Such user workstation must implement IPsec protocol to provide security. Here we have some usages here. Okay. Now here I have some traffic. Okay. This is my LAN. You see here? This is my LAN. All right. I want to send the traffic over the internet. But this is a very sensitive information. So I have to use VPN and send it in a tunnel. We call this VPN tunnel. Okay. Everything inside it will be encrypted. For this user here, he does not feel any difference. It's transparent, but it is securing the connection. Also here, I have a remote user. Here I have branch or network. Here I have only one user. Also, I can secure his connection. If you want to access your bank account details, also it's secure. Benefits of IPsec. I have already mentioned some of them. Stronger security. It is resistant to bypass within a firewall. So it's harder for hackers. It's below transport layer, so it's transparent to applications. Applications users, they don't feel the difference. It is transparent to end users and can provide security for individual users if needed. Remote access or to connect LAN to LAN. Okay. IP6 provides three main facilities: authentication, AH. This is you will need this when you do your lab. So authentication, a combined authentication encryption, ESP. Have you studied any of this in your cryptographic course? ESP or AH?
No, we studied something different.
Only key exchange function.
Okay.
DES.
Yeah, key exchange is part of this.
RES. And we studied, I think, the payload, but not ECP, something else.
Okay, it's okay. It's all right. A key exchange function also. For VPN, always we need to do, it's better to have authentication and encryption. That's it. This is the summary for this course, for this chapter, I mean. Please go over the slide. Let me know if you have any question. And let us also have a short break. Okay.